In this video, we will see the different ways that we have to express energy, the different units, and also the power. We will do this because when we go to the website to get data from the different agencies that work on getting the data of energy consumption, we will see that they use not just the standard unit that is the joule, but they use other units, like for example the kilowatt hour, because it's the traditional unit to talk about energy when we are working with electricity. And we also have the British thermal units and the millions tons of oil equivalent. This is for historical reasons, and this one because as we mainly get the energy from burning oil, another way to express the energy is to say how much oil we have to burn to get the same energy, and when we burn 1 million tons of oil, we get the energy of 41,000 terajoule. The other two, 1 kilowatt hour is 3.6 millions of joules, and the British thermal unit is 1,055 joules. To see why this is necessary, we will see the same data from these two agencies. One is the International Energy Agency and the other one is the US Energy Agency. Let's go to the International Energy Agency and see how much energy we get in the world from burning natural gas. To this, we go to this statistics data browser. We are going to the energy supply given by source, total energy by source in the world, and we get this data, and here we see the different ways to obtain the energy, and specifically for the natural gas, we get in 2020 so we get this amount of energy, that is 138 millions of terajoules. And if we go to the US Information Administration website, and once again we go to the data of total energy production, and we go to the natural gas, and we get for the 2020 this value is 144. The unit is quadrillions of BTUs. Okay, let's convert the two values that we get. On one side we get from IEA approximately 138 millions of terajoules. We will express it in exajoules as in the first chapter. This is 138 by 10 to the 6 by 10 to the 12 joules. This is tera, and this is the number of zeros here, and this gives me 138 10 to the 18 joules, that is 138 exajoule. This is the amount of energy that we get from natural gas in all the world in 1 year. On the other side, EIA gives us the value of 145 quadrillion BTU. We need to transform this quadrillion. Remember that this is million, billion, trillion, quadrillion, that is the same as saying 10 to the 15, and this is 145 10 to the 15 BTU, and now we need to transform it in joules, and it's the same as saying that 155 joules is the same as 1 BTU, to cancel the BTU, and the result is 1.53 10 to the 20. This multiplication, that is the same as saying 153 10 to the 18 joules. These are joules, and this is 153 exajoules. We can see that the two values are not the same, but are approximately the same. You have to consider that all these data, the data that are given the agencies, are obtained not by counting the real energy that is consuming, but by doing some assumptions and doing approximations. And because of this, the two results are not giving the same value, but as they are two approximately, we can say that more or less are the same. The important thing here is that in the two websites we have obtained the data from different units, and we have obtained finally approximately the same result. We are going to compare the total electric energy given by, once again, the IEA and the Enerdata Intelligence Consulting, that is another website where we can get the information. In the IEA, we have to go to electricity and heat and electricity generation by source. And here we can get the different sources of energy. On the other side, we can go to the total energy production, and here we have also the world energy production. We are going to compare the 2020 data. To this, we are going to sum all these data, the different values, and if we do this, the value that we get is 14,000 of millions of tons. And if we go to IEA data for these values, and we add all these magnitudes, all these values of energy for the different sources, we get approximately 584 millions of terajoules. Okay, now let's compare it. We have said that on one side we have obtained this amount of energy in millions of tons of oil, and this, remember, that has to be turned into terajoules, that is this multiplied by 41800 terajoules for million tons of oil, and this is giving us 6.819 10 to the 8 terajoules. That it's like saying 619,000,000 terajoules. On the other side, we get 684 terajoules. And once again, we see that two values are very close. So we can say that more or less are giving us the same unit. Remember that the agencies estimate the amount of energy is not obtaining really by adding all the values that we consume, but estimating the results. So are very close, and we can say that more or less are the same values. Let's now compare the values of hydroelectricity, that in this case are using the gigawatt hour. If we go to the IEA, electricity and heat and generation by source, we can get the hydropower, the hydroelectric energy from this value. On the other web, we can get the same value from this table, and we get this amount in billions of kilowatt hour. Okay, let's see if both numbers are the same. On one side, we get approximately 4450000 gigawatt hour, and on the other 4225 billion of kilowatt hour. Well, on this we can express it like 445 10 to the 6 gigawatt hour, and here 4225 10 to the 3 billion, that is 10 to the 9 kilowatt hour. Now we group these two numbers. This is 445 10 to the 6, and now giga is 10 to the 9 watt hour, and 422 10 to the 3 10 to the 9, and kilo is 10 to the 3 watt hour. And in both cases we get the same exponent. In this case 6 and 9 is 15 watt hour, and here 9 and 6 once again is 10 to the 15 watt hour. So once again we get the same values. If we want to convert it to joules, you have to remember that 1 watt hour is 1 watt multiplied by 1 hour, that is 1 watt multiplied by 3600 seconds, that is watt second, and 1 watt by 1 second is 1 joule. So this is like this amount of joules. When we convert this, we get 445 10 to the 15 watt hour, that multiplying by 316 is approximately 1.6 10 to the 19 joules. That, remember, that is approximately 16 10 to the 18 joules, that is 16 exajoules. Now let's talk about power. In this case it's a little bit it's more simple. We have the kilowatt, that is a multiplier, or gigawatt, or we will see, and then we have the horsepower, that it's not so used, so you cannot you don't have to worry about this. But yes, for the multiples of the watt. Once again, we will compare these two agencies, the nuclear energy. Let's see the amount of energy given by the nuclear power in 2021, that is 376 millions of kilowatts, and the international agency that gives us this plot, that is approximately 400 gigawatt. Okay, once again we see that 376 million of kilowatt is 376 10 to the 6 kilo 10 to the 3 watts, 376 10 to the 9 watts. Okay. That is the same that 376 gigawatts, and is approximately the same amount of EAI, that is approximately 400 gigawatt, as we saw.